Okay, this is a video on the 2022 Deferred Leaving Cert Exam question 1. I've just got the exam question there from StudyClix, and I'm just going to focus on part E, which is the calculations part. In the question, they've told you that you are going to analyse ammonium iron content of ammonium iron 2 sulfate crystals. So I've just written the full formula here for ammonium iron 2 sulfate crystals. And they told you that you weighed out 11.76 grams of those crystals and made it up to 250 centimeters cubed of solution. And then when I scroll down to the question, they've given you the full balanced equation. And they said in the titrations, 25 centimeters cubed of the iron solution made from the crystals requires 30 centimeters cubed of 0.02 molar potassium permanganate for a complete reaction. So I can fill in some of the information that they've given me from the question. From the actual balanced equation here, you can see that the potassium permanganate and the iron is in a 1:5 ratio. So we're going to base the answering of this question around that ratio. They told me that we used 30 centimeters cubed portions of potassium permanganate, and then we used 25 centimeters cubed portions of iron. And they also told me that you had a 0.02 molar concentration of potassium permanganate, and that was all the information that they gave you in the question. Now, the first question asks you to calculate the concentration of the solution in the volumetric flask in moles per litre of iron. So they want you to get this value. Now, in a lot of these questions, you're going to work across the way by using the ratio, but for the molarity in moles per litre, we're actually going to work down to the number of moles and then across and then back up. So I know that we used 30 centimeters cubed of 0.02 molar concentration potassium permanganate. So to find the number of moles, I'm going to multiply volume by molarity divided by 1,000. So the number of moles here is 30 centimeters cubed multiplied by 0.02 molar divided by 1,000. So the number of moles here on the left hand side works out to be 0.0006 moles, and that is how many moles would have actually been used in this titration, so in each 30 centimeters cubed portion. And then I can work across the way. So obviously my potassium permanganate was in a 1:5 ratio with the iron, so the number of moles that reacted is in a 1:5 ratio with the number of moles of iron that reacted. So to work across here, I'm just going to simply multiply that value, 0.006, by 5. So I'm using the ratio there. One of these will react with 5 irons, so 0.006 moles multiplied by 5 will react with 0.003 moles of iron. So that was the actual concentration reacting in the flask. Now, this is how many moles reacted in each 25 centimeter cube portion, because that's how much of volume of iron was actually used. So now I need to work back up here to get that concentration in capital M, which is moles per litre. So you can use this same formula, except this time we'd be subbing in the number of moles as being 0.003, the volume as being 25, and you would divide by 1,000, so molarity would be our unknown. So you could rejig around this formula essentially. If I was to just do some workings here, 0.003 moles divided by my 25 centimeter cube portion and multiplied by 1,000, that's me manipulating this formula essentially, or 0.003 moles is per 25 centimeter cube portion. So if I divide it by 25, it's telling me how many moles per 1 centimeter cubed, and then I multiply it by 1,000 and it tells me my moles per litre. So 0.003 divided by 25 multiplied by 1,000 gives me 0.12 capital M moles per litre. So that is your answer to part 1, which is the concentration of iron 2 in moles per litre. Okay, so I've worked down and across using my ratio there. The second question asks you the mass of iron 2 in the 11.76 grams of crystals that was made up into 250 centimeters cubed solution at the start. So I'm just going to rewrite out the molecular formula of the crystals. It's quite complicated. Okay, so we have ammonium sulfate bonded with iron sulfate and then bonded with water. Now, across that whole complicated formula, you'll notice there's actually only one iron in that whole formula. So if I had 1 mole of this substance, I would have 1 mole of iron. If I had 10 moles of this substance, I would have 10 moles of iron as such. So they want us to work out how much is in each 250 centimeter cube sample. We know here how much is in moles per litre. So we have 0.12 capital M of this whole complicated thing. So that's how much iron we have, Fe2 plus, to begin with. So if I wanted to actually work out the mass of that, mass is equal to moles multiplied by relative molecular mass. I am going to actually multiply my molarity by the relative molecular mass of iron, which is 56 grams. And that would give me essentially a moles per litre value of just the iron by itself, which would be 6.72. Now, because I worked in moles per litre, this is my value in grams per litre, but the question actually asked me for a mass in each 250 centimetre cube portion, which is what we made up at the start. So to go from grams per litre back to grams per 250 centimetres cubed, I'm going to divide that value by 4. And that would give me 1.68. So this is how many grams of iron there are in each 250 centimetre cube portion of the crystals that were measured at the start. And the last thing the question asks you to do is calculate the percentage by mass of iron in the crystals. So percentage by mass of iron in the crystals overall. So the amount of iron that was in the crystals is 1.68 grams. The mass of the crystals that you weighed out at the start is 11.6 grams. And to get a percentage, you multiply by 100. So 1.68 divided by 11.76 multiplied by 100 gives me 14.285. I'm just going to multiply that to 29%. So that's how much of my ammonium iron 2 sulfate is just iron.